on this tutorial today. Today I'm going to be showing you how to perform the approach and landing in the AV8B Harrier for a conventional landing. So the first thing we're going to go through is how to set up the aircraft for the approach. So it's really simple. Generally you want to have either the station TACAN of the aerodrome you're going to tuned in, or you want to have the waypoint inputted. In this example I have the waypoint inputted, and you can see that on my LFD down here. I'm just going to decenter that so that's at the front, and I'm going to stick the scale on auto so that I get the best heading, best view. Next thing I'm going to look at is the heading. So there's a couple of ways that you can get in the course line, and this will help you make sure you're aligned with the runway, especially in low visibility, but also for things like the circuit and stuff to that sort of nature. So to do that, you just press and hold the nav course button, and you can either click it to align it, which is a perfectly acceptable way of doing it, or if you know the heading, after holding it, you'll see up here on the UFC, you start to get a heading. You can just punch in a 3-digit heading, 360, 090, 270, whatever it is, hit enter, and that'll align it with the runway. Okay, so next we're going to configure for the actual approach itself. So that's pretty simple. We want to make sure that water is off for a conventional landing, flaps are in auto. We're going to make sure that our nozzles are all the way forward. We're going to make sure our gear is down. We should get 4 greens. There we go. Okay, and that's us configured for the approach. Okay, so next we're going to discuss the approach itself. The approach should always be conducted in the VSTOL master mode, which can be enabled by pressing the VSTOL option here. And basically what we're going to aim to do is have a 3-degree glide slope with the witch's hat, which is this little guy here on the horizon. The witch's hat tells us where the nose is pointed. So we're going to use the stick to control our speed, and we're going to use the throttle to control our rate of descent. Okay, and we're going to judge the rate of descent by looking at the velocity vector, which is this guy here. It's also called a donut, owing to the fact that it's a circle. And more or less what we're going to do is we're going to pop that on the runway. A couple of checkpoints that are really useful: long finals and finals position. Long finals position is 2,000 feet above the runway, at a distance of 8 nautical miles from the touchdown point. The finals position for a straight-in arrival specifically is 4 miles from the runway at 1,000 feet above the touchdown point. So again, it's all about getting yourself and getting that correct glide slope. So we're looking for a 3-degree glide slope onto the runway itself. Okay. How can we avoid breaking the plane? Well, we want a positive rate of descent when we touch down. So generally, you don't want the donut to come below the 5. That will mean that you've got a descent rate of more than 500 feet per minute. It generally means you're going to break the aeroplane. You can also double check the descent rate by looking at the feet per minute here. Okay, so we'll go ahead and we'll fly the approach now. Alright, so I'm just going to reduce the power because I don't need to be that fast. Popping the nose on the horizon and trimming it. We can see the flaps have come down there and we've ballooned. Getting the nose down to kind of counteract that. Okay, that's coming back down, so I'm going to catch it by bringing the power up because the engine takes time to spool up. There we go. We can see we're at 10.8 miles there in the right hand side of the hood. So we're not quite ready to descend just yet. So I'm just going to trim that straight and level until I'm comfortable with it. Okay. There we go. Looking down at the AHSD, we can see that our nose has come off where we want it to be. So we're just going to turn in back toward the runway, and if we look out of the front, we can see there that the runway has moved off to our left as we have moved off to the right, so we're going to move across. Okay, we're at 8 miles now, so I'll start descending. To do that, I'm just going to reduce the power gently. As you reduce the power, you'll notice that the nose tries to drop. So what you need to do is just gently ease the nose up by pulling gently on the stick and then trimming it to release that pressure so that you don't have to hold it there the entire time. There we go. And of course you'll find a reduction in speed because as you move the nose up and increase that angle of attack, you increase drag. Okay, so here we can see that we're actually just shy of the runway, so we're going to control our rate of descent and increase the power, bring the nose down to increase the speed, which will in turn increase our lift. And now we're overshooting the runway quite considerably. So if you find yourself in a position like this, you'll find yourself pushing the nose forward to keep the witch at the horizon. So just reduce the throttle, find that the nose drops, so ease back on the stick, and the velocity vector drops. Remember, you're going to bring the power back up like I am now. You can probably hear that. Because it takes some time. If you wait until the velocity vector hits the 5 on the ladder down there, and then bring the power up, you'll find that it's continuing to descend whilst the power's coming back up. So you always want to preempt it. Okay, we're at 4.5 miles now. We're at about 1,000 feet, so that's good. See our AOA on the left hand side is 11, that's good. We want to be between 10 and 12, and generally that's how you'd gauge the speed. There are so many different speeds you can land this plane at because of all the different weight configurations that you don't have a landing speed, you just go based upon the angle of attack. See there, we're overshooting the threshold of the runway very slightly, so we're going to reduce the power a wee bit, and even just that tiny reduction in power is causing the nose to drop. Okay. I'm just going to fly this all the way down now, using the nose to control my speed, and the power to control my rate of descent. Tiny input, so really just inching that power back there. You can see the RPM flicking back to 79 as I've reduced the power a tiny amount. Okay, and I'm just letting the aircraft creep over to the left so that I can line myself up on the centre line. Using that radio beacon below me as a reference. Turn it back on the centre line now. There we go, we can see we've got a good rate of descent there. Now at this point we've raised the witch's hat literally to there, no higher, otherwise you'll tail strike. Let it touch down, close the throttle, use rudder to keep it centralised, nozzles all the way back to the braking stop, and gently apply power to no more than 60% RPM. Using rudder to keep ourselves on the centre line. And once you're below 60 knots, you can start to use the brakes very gently. Close the throttle, nozzles to 60 for the taxi, and that's all there is to the landing. Okay, so in this scenario we're very low. As you can see, that's the runway up ahead. We're at about 500 feet, about 5 miles. So what you'll find people sometimes do in these scenarios is, as you can see here, is just readjust to pop the velocity vector on the end of the runway. The big issue with that is obviously there's obstructions, some of them you might not see until it's too late, power lines, radio masts, so on, and you end up flying into them. Obviously, if you're going on to do instrument flying, that's a really big no-no, because you want to build and maintain those good habits, so that when you're in those poor conditions, you know that you are confident in doing things the right way. The other thing people often do is not touch the power and pull the nose up, which again induces a stall as you pull through the critical angle of attack. So what you want to do is just add the power, and get yourself up to one of the gates. Reduce the power, bring the nose back on the horizon. You'll see the velocity vector is going to fall through, and I just add power to catch the velocity vector and arrest that rate of descent where I want it. And 500 feet at 2 miles. Alternatively, you could just fly straight and level until one of the gates, which is at the altitude you want to be at. So if you're at 1,000 feet at 8 miles, you just continue flying straight and level until you meet 4 miles, and so on. And then you just fly the approach as normal. Trim it as you go. Again, notice when you add power, the nose tends to pitch up, and as you reduce power, the nose tends to pitch down, so you need to just play with that as you go. There we go, and as you're getting close, just bring in the nose literally 1 or 2 degrees with the horizon, touch down, close the throttle, and begin positive nozzle braking. Okay, so let's say like in this scenario, you're extremely high, and you want to settle back on the glide path. The common mistake most people make is they'll either just resettle the velocity vector on the end of the runway, which means that you're now descending at a really high rate of descent, and you'll obviously be very fast as a result. Or they'll drop the power all the way back so that the velocity vector drops below the line of the hood, and that's how you induce a stall, and ultimately, if you don't correct that quickly, you will crash. Or people stuff the nose down without touching the throttle and get themselves low and fast. So the correct way to respond to this is to watch your angle of attack, reduce the throttle accordingly, and just gently drop the nose. Generally, you want to drop the nose shy of the runway and then adjust the power. So you can see that the power's dropping. So you need to be quite corrective with the throttle because the engine takes time to spool up. And you want to bring the velocity vector up so that it almost matches the witch's hat. Okay. So we're probably wanting to be at about 500 feet now. 2 miles, so we're going to continue with that rate of descent to get ourselves back to another one of the gates. So there we go, 2 miles, 500 feet, bringing the nose up. And as I bring the nose up, I'm just playing with the throttle just to put the velocity vector on the end of the runway. And then I'm trimming it to keep the nose on the horizon, because I don't want to hold that stick the entire way down. There's no need. I've got the trim to do that for me. So there you go. That's all there is to it. Get the nose down, reduce the power. Once you're back into one of the gates or about to approach one of the gates, add the power and bring the nose up, and then just reduce the power to get that rate of descent on as the nose meets the horizon. Then again with the landing, pulling the nose no higher than this, walking it all the way down on the ground, close the throttle, nozzles back, and begin the positive nozzle braking again.